Hi, this is Steve Button from the WebLogic Server Product Management team. Thanks for joining us for this Oracle Virtual Developer Day. Today I'd like to give a short presentation covering the use of Maven with WebLogic Server and discuss some of the new features we've added to the latest WebLogic Server 12c release. As an agenda for today, we're going to provide a brief recap of Apache Maven. We'll then provide some insight onto the new features we've added in the latest release of WebLogic Server 12.1.2 that support the use of Maven. Finally, we'll finish off with a couple of short demos that demonstrate how to use the new archetypes provided with WebLogic Server and also how to use the Oracle Maven artifacts that we push into a repository inside your own Maven projects. Alright, let's have a bit of a brief recap of what Maven is. Maven is a popular open source project that's used to manage a large number of software development lifecycle tasks. You can use Maven to define your project structure and its hierarchy, manage the build of your applications, define dependencies and have them automatically managed, and much, much more. Maven uses a plugin framework so you can wire in specific behaviors for different software lifecycle phases. Maven comes with plugins out of the box, and there are also a vast array of open source third-party plugins that you can use with Maven to pretty much accomplish anything you need to do in order to build, package, deploy, test, validate, etc. For your project. There are plugins for testing, deployment, code generation like JaxB, JaxWiz, pre-compilation, as we'll see a little later on. Maven is now a very mature project run under the Apache Open Source Foundation. It was first produced around 2004, and over various iterations we're now looking at Maven 3.1. The primary construct in Maven is something we call a POM, a Project Object Model. The POM enables you to define your project with a group ID, artifact ID, version, and type. This effectively forms a unique identifier for your project. You also use the POM file to declare dependencies that your project has on other libraries or other projects, and you also use it to define the plugins that you want to execute as part of the software lifecycle. One of the great things about Maven is that this POM file itself is portable. What we mean by this is that since the POM effectively defines the project, its dependencies, its build steps, etc., it means that it can be ported into any IDE that provides support for Maven and used, because it's effectively self-contained. This enables multiple developers to very easily work on a project using the IDE of their choice and not be locked down to a specific IDE with a specific project structure and settings. Maven advocates the use of conventions over configuration. What this means is that Maven has a default project structure and many default behaviors that are typical for software projects. For instance, when you place your application and test source files in the right place within your project, Maven will automatically know how to handle them, to compile them, execute the tests, perform packaging sequences, etc., with no additional coding or configuration required on the developer's part. Maven knows how to use the conventions in order to fulfill various tasks. Maven also has a well-defined project lifecycle, so you can choose to wire in plugins at some or all of the phases of this lifecycle to define the behaviors that you require specifically for your project. For example, as we'll show with the WebLogic plugin, you can configure your Maven project to automatically deploy an application when a specific phase called the integration test is executed. Maven's based around the central concept of a build lifecycle. This is a well-defined cycle that consists itself of a set of phases. In order to use Maven to manage the lifecycle of your project, you really only need to learn what amounts to a small set of commands, since all of the configuration information is stored in the POM itself, with a lot of that being actually used in a conventional manner, so it's built directly into Maven itself. There are 3 built-in life cycles: default, clean and site. The default cycle handles your project deployment, the clean life cycle handles the cleaning up, and the site life cycle handles the creation of your project site's documentation. Each life cycle has a distinct set of phases, and each phase has a set of goals that performs the actual tasks. You can extend the default behavior of the Maven lifecycle phases by using plugins and tying them, as we've said, to specific lifecycle events. This saves a lot of work over other typical build environments such as Ant or Make, where as developers you need to go ahead and actually create the sequence of steps required to package, compile, etc. Maven handles a lot of that for you. These are the most commonly specified phases of the default Maven lifecycle. It includes the major steps in the project lifecycle, from validating the configuration through to compiling, packaging, deploying, testing, etc. When you specify a Maven phase, Maven executes all of the phases up to and including the specified phase. The final point we'll touch on in our Maven recap is the use of repositories. Maven repositories store artifacts that you create, dependencies that you need, and plugins you use as part of your software project lifecycle. Repositories can be both local and remote. The local repository essentially acts as a cache of remote downloads and holds temporary build artifacts that haven't yet been released. An example of this would be a project that you have packaged for use on your local machine. A remote repository stores remotely accessible artifacts. This can be truly remote in the sense that it's hosted on the internet and accessible by anyone, or it can be a corporate repository that's held behind a firewall that holds artifacts, plugins, projects, etc. for your specific company. When Maven's trying to find a dependency or a plugin, it first looks in the local repo, and if the dependency is not available, it then searches the default and any subsequently configured remote repositories. Maven has a default public repository, and there are many other public repositories that you can use to retrieve dependencies for your projects. And as we'll talk about today, this concept of repositories and the publishing of Oracle libraries into a local or a corporate hosted Maven repository is one of the key new features we've added in this release. Alright, so that brings us to the next release. Let's now take a look at the level of support for Maven we have in WebLogic Server 12c in the 12.1.2 release. What we've provided in this release is a number of things that enables WebLogic Server to be used, I guess, more synonymously with Maven. So the first thing we've provided is, as part of the actual product installation, we now provide the distribution of Maven itself. So with 12.1.2 we've provided Maven 3.0.4. This is installed with the product and it's put there as a convenience. You can choose to use it, or you can use the other versions of Maven you already may have set up within your particular environment. We have something we call a sync plugin, and the sync plugin's role is to take a set of prescribed libraries from an Oracle installation and effectively turn them into artifacts that are pushed into a targeted Maven repository. We provide the WebLogic Maven plugin, which provides operational support for working against WebLogic Server from within Maven projects. And what we believe all of these things enable you to do is effectively adopt and use the standard approaches for working with Maven. So now with the Oracle artifacts published in a repository, you can reference them and use them from within your own projects using an Oracle supplied namespace or a coordinate system. And that helps provide consistency across your projects, because anything that now needs an Oracle supplied library or an Oracle artifact is using the same coordinate system. Alright, let's now drill down into using the Oracle Maven-Sync plugin, and we'll have a look at what this new plugin's role is within the Maven integration that we have. So the role of the Oracle Maven-Sync plugin is to take a set of libraries that have been marked out from within a WebLogic server installation and push them up to a targeted Maven repository. It does this by searching through an Oracle home and looking for POM files. So for every artifact or for every library that we want to push up into a repository, which we've identified as being an API, a client library, or some other jar file required from some of our plugins to support their operations, we've created an associated POM file. So the Oracle-Maven-Sync plugin looks for these POM files, locates the associated jar file, so the library from within the Oracle home, and it takes these two things together and pushes them or installs them into the Maven repository, therefore publishing it as an artifact that can then be used. The Oracle Maven-Sync plugin is again a Maven plugin itself, so it needs to be installed into the repository so that it can be used. The Oracle Maven-Sync plugin can support installing artifacts into a local repository or to a specified remote repository via any of the standard repository managers such as Archiver, Nexus, Artifactory, and so forth. So how do we go about using the Oracle Maven-Sync plugin? The first thing we're going to need to do is locate the Oracle Maven-Sync plugin inside the WebLogic server installation, and the path is shown in the text box there. The coordinates that we supply to be used to install the sync plugin are the group ID com.oracle.maven, the artifact ID is Oracle Maven-Sync, and the version is 12.12-0-0. So the first step you'll need to perform in order to use the Maven-Sync plugin is to install it. And to do this, you use the standard Maven install file goal, specifying the path or a property with a file, specifying the jar file, and another property for the POM file indicating where the POM file lives. Once you've actually installed the sync plugin, the next step is to execute it. So the simplest case here is to push the libraries from a specified Oracle home into a local repository. The syntax for doing that is shown in the text box here. So you execute Maven, you specify the name of the plugin, com.oracle.maven, Oracle Maven-Sync, and then you specify the goal you want to execute, which in this case is the push goal. The push goal requires some further information, which is specified via the system property, Oracle-Maven-Sync.oracle.home, and that should point to the directory which you wish the push goal to iterate over, look for POM and associated jar files to push up to the repository. So it identifies the Oracle installation that you want to scrape and use the libraries from. There's some additional options you can specify for the push goal. The first one we'll look at here is a way to effectively perform a dry run to get a view of what will get pushed to the repository. In this case, you specify again executing the push goal, you nominate your Oracle home directory, and then you provide a further property, Oracle Maven-Sync.test only equals true, and in this case the Maven-Sync plugin will perform all of the tasks, look for the POM, the associated jar files, but it won't actually proceed with performing the installation. So it effectively performs a dry run. The other option we have here is where we want to push to a remote repository. So your remote repositories are typically configured in the local settings.xml file, and it's given generally an ID or a reference indicating the configuration for a specific repository. So to target the push operation against one of those remote repositories, you can then specify a further property, Oracle Maven-Sync.serverID, and then give it the name of the remote repository that's specified in your settings.xml file. With that, we'll just do a quick demonstration. So here I have the command line from my local client. Just to save some typing, I'll go back through the history, and here you can see I'm going to execute the Oracle Maven-Sync push goal. And here I'm specifying the Oracle home I wish to look at, and I'm also going to specify the property to execute the test only, so to perform a dry run. But if I go now ahead and enter, we'll see what that does. So it's completed in its dry run mode. If I scroll back through the output, we can see that the push goal indicates it's running in test only mode, so no changes are going to be made to the repository. And I guess one of the interesting things is that hunting through the specified Oracle home, it found 209 location files, which are the I guess the pointer between the POM and the actual jar file. So by executing this push goal on that specified Oracle home, we'll have 209 artifacts pushed up to my local repository. After the push goal is executed, really you can take a look at what is contained in the repository, utilizing any number of techniques. If it's fronted with a repository manager, such as shown here on the screen, Archiver, you can look through for the com.oracle namespace and see the groupings of artifacts that are pushed up. What have we chosen to push up in this release is all of the common and public APIs for WebLogic Server itself, for coherence, for toplink, so the programming APIs. We've pushed up any utilities that are thought to be useful from a Maven perspective, and also any additional libraries that are needed for our plugins to operate or for various other things to occur. We've also provided with this release a small set of archetypes, so Maven archetypes that cover some basic examples of application structures for WebLogic Server, so covering web applications, MDBs and so forth. We'll cover that shortly. And the Coherence team have also produced an archetype that will help build a skeleton project for their new grid archive. We also push up plugins as part of the push operation, so that'll include the WebLogic Maven plugin and also the new Coherence GAR plugin. So by executing push, we'll get APIs, libraries, utilities, archetypes, and also the plugins that we've provided. So it's effectively a one-off operation to populate your repository, and you can then start using both the artifacts, plugins, archetypes that we've provided. Alright, so that's the Oracle-Maven-Sync plugin covered. Let's now take a look at the WebLogic Server Maven plugin. So before we get into it, I just want to do a brief history here of Maven and WebLogic Server. We've provided Maven support with WebLogic Server all the way back from WebLogic Server 10.3.4, where we first introduced a basic plugin that provided support for deployment operations. This plugin at this time was developed as essentially a plugin that contained the full WebLogic Server client, in addition to the small Maven plugin classes. So in event, what you had here was a plugin that was in the order of about 70 megabytes that needed to be pulled down to developers' machines and executed. With the release of WebLogic Server 12c, 12.1.1, we did a little bit of work to add some additional goals that we thought would be useful to the plugin to support more of a full operational lifecycle. And these were things such as performing an installation of WebLogic Server itself, creating domains, executing start-stop server commands, executing WLST to execute scripts or commands, using the WebLogic scripting framework to create resources, etc. A change that came about here was twofold. First off, we changed the name of the plugin, or introduced a new plugin, which was WLS Maven plugin. And this edition of the plugin also required a local installation for the goals to operate. So it didn't actually use classes from or libraries, dependencies from a Maven repository. It actually pointed to a local WebLogic Server installation. With the advent of the 12.1.2 release, we've further enhanced it such that now the WebLogic Maven plugin can run from using libraries that come out of a repository. So we've got dependencies, we're using the artifacts that we've pushed out in order to provide the libraries needed for our plugin to operate. Most of the goals in this release can run from the repository, so mostly the deployment-related operations. We still provide support for the, the construction, the installation goals, so install, create domain, WLST, etc. Those things still have a reliance on a local WebLogic server installation, so that's an optional configuration you can supply. We've also added some web services goals to this release. So there you can see we've provided support for Maven for a number of releases, and it's sort of varying over time, but the new WebLogic Maven plugin from 12.1.2 is showing the direction we're moving forward. Now we have artifacts in a repository that we can rely on and use. Alright, so in this release, the WebLogic Maven plugin has a group ID of com.oracle.weblogic. It has an artifact ID of WebLogic Maven plugin, and as you would come as no surprise, the version is 12.1.2.0.0. As I've said already, it provides operational support, or provides the ability to execute operations against a WebLogic server instance from within a Maven project. Install WebLogic server, create domains, start servers, execute WLST scripts, and so forth. It also has more application-oriented type support as well for deploying applications and libraries, start-stop applications, pre-compiling application packages, generation of web services, etc. And as I've mentioned, the goals on the right there can run remotely now, so they no longer have a reliance on local WebLogic server installation. The goals we have in specific, to drill down here, I've grouped them into a number of categories. So the first category is a sort of server-based operation. So this is where I'm actually going to perform things such as the installation of a WebLogic server from some form of binary distribution, a zip file or the generic jar file. I can create a domain from the plugin. So essentially what this does is executes a create domain operation using a known domain template. So it gives you the ability to specify the name or the location of the domain. The name will be derived from that, a username and password. So fairly straightforward. For more complex domain creation options, we recommend the creation of an associated WLST script and then execute that from the WLST goal to further refine or tune your domain. We can start a server and we can stop a server, so this is important as part of a testing lifecycle at times. We can currently uninstall a WebLogic server instance that has been installed with the zip installer. We're looking at enhancing that to support also the generic based installer in subsequent releases. And again, we can execute WLST. So given commands or a specified script, we'll fire up WLST and execute those things against a target server. This is pretty useful for creating and managing resources, JMS, destinations, connection factories, etc. We then look at the deployment and lifecycle goals. So here we provide support for deployment of applications to WebLogic server, supporting all of the standard deployment packaging models, WARs, jars, EARs, and the new coherence CAR. We've got operations to obviously redeploy, undeploy that same application. We can execute a list application goal, which will list the deployment names for the applications that are against the target server. We can start and stop an application and so forth. So fairly comprehensive support for application style or application oriented operations against WebLogic. We've also got support for AppC, so this is where we're going to pre-compile a deployment archive in order to, for archives that have lots of JSPs or EJBs, the translation, generation, compilation, etc. is done at development time, so during deployment time it doesn't take as long to deploy on first call. And then finally we've added support for web services, so client generation, so generating web service artifacts from a WSDL definition. The WSDL C, so generate partial Java implementation stubs of a web service from WSDL. We've got a packaging goal in there with JWSC. We've also got a long-standing help goal which provides a description of each of the goals available in the plugin. We see this as being deprecated in 12.1.2, meaning it still works, but the preference now is to utilize the standard Maven help describe goal and specifying the name of the plugin or the name of the goal you're interested in to get that information from Maven directly. So how do we go about using the WebLogic Maven plugin? So the first thing we're going to do is obviously run the Oracle Maven-Sync plugin to populate the repository. with all the artifacts and with the plugin. That's a one-off task. You're then going to edit your project pom.xml file and add a plugin definition for the WebLogic Maven plugin. You then go ahead and provide some configuration values for the plugin to use, username, passwords, application names, etc. So the information the various goals are going to need. And you'll then go ahead and bind the goals from the WebLogic Maven plugin to the required execution phases of your project lifecycle. For instance, you may want to bind in deployment to the pre-integration test phase. So anytime you're going through an integration test, you'll actually deploy the application to a target server. Here's an overall example of a pom.xml file that has the WebLogic plugin configured. This is demonstrating here basically the placement of where plugins belong. So plugins are defined within the build section of your overall project. Let's expand the plugin section there now. And expanding the plugin section, here we can see the definition of the use of WebLogic Maven plugin. So here we can see we've specified the group ID, the artifact ID of the plugin that I want to use. I've then provided effectively an execution binding to say that anytime this project goes through the pre-integration test phase, I want to execute the deploy goal from this plugin. And when that deploy goal executes, here's the configuration that I'm going to use. In this case, I'm inheriting some of the username and password from a parent project. We have a parent POM called WLS common, which has names, placeholders for username, password, server admin URL, etc. that can be referenced and used from different plugin definitions. So it enables us to store that information in one place and then reference it. It also enables it to be changed at that POM level outside of your project, so you can actually take your same project code or your same pom.xml file through your various states of dev, test, UAT, etc. without needing to change information in the pom.xml itself. It being decoupled and stored externally in a parent POM enables it to be changed at that point. So here are those informations. If this goal, or if this plugin definition was executing a goal that required a local WebLogic server installation, this is where that server installation will be specified using the middleware home configuration value. You can see here it's commented out, so it's not needed to execute the deploy goal. There's the phase binding, there's the configuration. What we have now is a further example, which is demonstrating or showing off how to actually call a WLST script from the WebLogic Maven plugin. In this case, middleware home configuration setting is required because WLST executes locally in the current release. Again, we're looking at seeing how we can address that for future releases to enable WLST to be executed remotely as well. In this case, I'm still doing a pre-integration test phase binding, but in this case, I'm executing the WLST goal. I'm passing the configuration, which is going to consist of the server URL, the username, password, etc. And then I'm specifying the name of the script file that contains the WLST commands to execute. What's important to note here is that when Maven goes through its phase bindings, it's going to look at the sequential order of them, and it will execute them in that order. So in this case here, I'm looking at having my config JMS resources execution executed before I deploy my application. So the use case here is that I want to create, for a JMS use case, some connection factories, destinations, etc. Have them pre-configured before I deploy the application, which is then going to go ahead and subsequently use those resources. Alright, so that's the short and sweet overview of WebLogic Maven plugin. Obviously there's a lot more you can do with it, so I'd encourage you to look through the documentation, which is fairly extensive in this release, to get some more insight into how to go ahead and use it, create profiles of use, etc. There's a lot you can do with it. The next thing we want to look at is creating projects from the Oracle Maven archetypes. So in this release, as I said, as part of the artifacts that we're pushing up to a Maven repository, there are a number of archetypes. Maven archetypes are a standard Maven convention for providing what amounts to starting points for developers to start building projects or demonstration codes, etc. So it essentially gives you a way to create a new Maven project from a starter or from a bootstrap type template. With this release in 12.1.2, we provide 5 archetypes. These cover a number of basic and fairly simple examples of different technologies you can use within WebLogic Server. For instance, the basic web archetype demonstrates how to use JSF CDI and what a WebLogic Maven plugin configuration looks like to deploy that against a target server. We've got again a basic web app, but also adding an EJB. So in this case, we're using a JSF CDI and JPA to persist some information into a database. We've got an example with MDB, which then has a requirement on JMS resources. So it includes an MDB example, but also a WebLogic Maven plugin configured to execute a WLST script. We have a web service example, and the coherence team have produced an archetype that will actually create a skeleton for a Maven project that has the configuration files and structure for one of the new grid archives. These archetypes are installed into the repository, so you should be able to execute them after you've done your push goal and you further executed something we call the Maven archetype crawl goal, which is going to go ahead, traverse through your repo, look for archetypes and store them in a configuration file that can be used. Alright, we're going to do a quick demo here of using one of the Oracle Maven archetypes. The environment I'm going to run from is NetBeans WebLogic Server 12.1.2. I'm going to generate an archetype, in this case the basic web app, which is going to produce for me source code for JSF CDI. It will have a Maven POM file with the pre-configured WebLogic Maven plugin. And we'll then step through and we'll deploy it and have a look at what that archetype looks like, or what that project looks like that is created from that archetype. So let's go to NetBeans, create a new project. NetBeans has pretty good support for Maven, likewise so does Eclipse and Oracle Enterprise Pack for Eclipse and the other IDEs that are out there. So what we'll do here is we'll actually go ahead, create a new Maven project. We'll specify we're going to create it from an archetype. These are all the archetypes that my NetBeans instance currently knows about. I'll narrow the search down to the Oracle, to include Oracle. In this case, I'm now going to select the basic web app archetype. I'm going to give it some information, so I'll give the project a name, change the version, and we'll go ahead and click finish. Alright, so what we have here now is basically a brand new Maven project that's got some pre-supplied source code in it. So here's a JSF page. It has a Java bean associated, which is a CDI managed bean, and it also has, in this case here, a Maven POM file, which is configured with dependencies on the Java EE6 web API. It's got some plugins developed in this pre-configured, in this case the Maven compiler, the Maven War plugin, and it's also got the WebLogic Maven plugin configured and configured to execute in the pre-integration test phase and perform a deployment operation. Alright, so I now should be able to just execute build, and this is going to go ahead and go through the Maven install lifecycle, which is going to compile, package, and then ultimately deploy the application to my WebLogic server instance. And there it is. So I've gone from having nothing to a deployable, testable application in about 2 minutes. And as you can see, it's functional, so I'll deposit some money. Deposit 0 doesn't really help much, Steve. Deposit and deposit. So there you can see it's a very simple example of using JSF with CDI with a WebLogic Maven plugin configured inside the POM file to get a project up and running. Alright, so what we'll now look at is developing with the Oracle Maven artifacts. So one of the positives that we get from pushing the Oracle libraries into the Maven repository is that not only do we have plugins and the archetypes available, we also have now our public APIs, and various other jar files that you can utilize in your own specific Maven projects by simply declaring a dependency on them. This avoids for the first time the need to use non-portable workarounds such as the use of the system scope and the system path settings, which I've seen people do, or customers defining their own coordinates for a set of Oracle libraries that they push up to the repo. It provides an Oracle supplied I guess namespace, version, etc. for the set of libraries we think are important to be accessed from Maven. Alright, what we're going to do now is another demonstration where I'm going to go back into NetBeans. I'm going to generate a new web project. I'm then going to build out very quickly an application that uses the new WLST WebSocket API that uses coherence and then deploy and test it. So in this case I'm going to be demonstrating how I can add dependencies on Oracle Coherence and the Oracle WebLogic Server Web API from NetBeans and have that fulfilled from the Maven repo. Alright, in this case I have a project already built out, standard Maven web project. Alright, here's the POM. The artifact ID is VDDWS. It has, in this case, a JSP page which is acting as a WebSocket test client. So this is something I borrowed from the we borrowed from the websocket.org. It's just very basically a WebSocket Echo test client. So that's part of the web application. What we'll do now, very briefly, or very quickly hopefully, is we'll add a WebSocket endpoint. So I'm going to call this one Echo WebSocket, new class, and that'll give me basically a standard Java class. At this point I know that I want to annotate this class with @WebSocket. And NetBeans is reporting that, hey, I can't find @WebSocket. Do you want to search a dependency in the Maven repositories? I'm going to say yes please. What it's now come back with is said of the Maven repos that I know about, and in this case it's a local one, I can find this class in this artifact. Do you want to bring it in or add a dependency to it? In this case I'm going to select yes. So what I now have is the ability, or I now have that API available for me to use for my code. So I can import that class. I can now specify a path pattern to use, and I can add out the actual code to make a new WebSocket listener. Alright, so what else I might want to choose to do is say I want to add coherence. So another way I can add dependencies is I can come in, I can click on dependency, and I can search for a named class. In this case, then I'm going to use something called name cache from coherence. So instead of having to find coherence, add it to the class path, I simply look it up, add it as a dependency of my project, and coherence will then be available for me to use. So we'll import it. Okay, so at that point I've now created an instance of a name cache called messages. I've got some code here now I'm simply going to import, and what this does is basically adds an onMessage method which is going to be called when WebSocket messages come in. I'll go ahead and fix the imports up. And in the WebSocket, in the onMessage, basically I get a WebSocket connection and I get the message come in. I'm storing that message in a coherence cache called messages, and then I'm responding to the connection by saying, hey, Echo WebSocket received your message and the message was X. Alright, the final thing I'm going to want to do is add the WebLogic Maven plugin. So again, I've got a shortcut set up. Here you can see it's just the standard WebLogic Maven configuration, bound to the deployment phase, bound to pre-integration test. I'm going to perform a deployment. So with that now, I should be able to simply go ahead and execute a build. The Maven project's going to be executed, going to be compiled, packaged, and ultimately deployed to WebLogic Server. So now I should be able to see that I can access that application which is compiled against dependencies that have come from a repository, so I haven't had to go and hunt and pull down any of these packages. It's all been done via the magic of Maven. And I'll go ahead now and I execute my test client, and you can see that it's connected to the WebSocket, it sent a message, got a response back, and then it's disconnected. I can show that the coherence nature works by here I actually am using the coherence query interface. So I can do a select of the key of the value from the actual messages cache. So there you can see that message that I received was pushed into the cache. If I execute it again, simple reload, execute again, you can now see I have two messages. So what I've demonstrated there is I've been able to use the WLS WebSocket API and coherence as basically satisfied as Maven dependencies. Very cool. Okay, let's finish up. So finally, what I just want to point out is that given our focus on Maven, we've actually developed a focus on Maven, continuous integration, supporting agile development frameworks, etc. As of the 12.1.2 release, we've produced a new piece of our documentation library. It's a book called Developing Applications Using Continuous Integration. And what this does is basically provides a walkthrough of using or establishing a continuous integration practice, all the way from establishing good source code control practices, looking at build automation, dependency automation with Maven, looking at binary repository management using, in this instance, I believe was Apache Archetypes, and then looking at establishing continuous integration testing regimes, so using Hudson in this case to put in place continuous integration testing. So I'd thoroughly encourage you to go and take a look at that book, get some ideas from it, or at least review how you're doing CI against how we sort of see it happening. And this is just an example of how we are starting to provide more information, more support around the use of Maven, CI, DevOps as we move forward. So we've got lots of information out there about using WebLogic Server, about using Maven. Here's some of the examples. We've got the Maven plugin configuration guide. We've got developing with Maven. The TopLink team have got a white paper on using Maven with Oracle TopLink. There's also some YouTube postings from Mark Nelson that covers a bit more information about this synchronization plugin. We also have Tim Middleton from the Coherence engineering team showing you how to use Maven with Coherence. So, check them out on YouTube. Look for Oracle Maven, Oracle Coherence, and you'll find these video references. All right, so just in summary, thanks very much for listening today. But just to wrap up, what I've basically covered is, we've made significant investments in Maven, which have been delivered in the first instance with WebLogic Server 12.1.2. We believe that this is going to now enable a consistent use of Oracle libraries from Maven projects via the Oracle-Maven-Sync plugin that we've provided, via the artifacts, the consistent naming and versioning schemes we've got. We've also provided updates to our plugins. We've provided some basic artifacts. We look to see more of those evolve over future releases. We've provided documentation updates. We're starting to generate white papers, etc. So, it's sort of evidence of our real interest in this area. So once again, thanks very much for listening. Hope you got something out of it, and look forward to the next Virtual Developer Day.